Good evening. Looks like I forgot my hat upstairs. Oh well, we're gonna go with it anyways. Messy hair, don't care. Yes, thank you for following. Snobbish. I can't quite read your full username. So let me know in the chat what you prefer to be called. If you want to, if you have a name or nickname or how you pronounce the last letters in your name. But welcome to the stream, nevertheless. I decided that I would stream because I have some things I can test on the Zoxbox. And I am now live. Pro note, if you change the password on the account used to log into Streamlabs OBS, give yourself an extra few minutes to log back in. Otherwise, Streamlabs not going to be able to log into the video provider that you use to authenticate. So I see that I don't know that I have anyone watching just yet, which will give me a chance to right a wrong. And that is I forgot to plug in my 9-volt power adapter. And so that I don't completely detach the power strip from my desk, I will walk around and do that. My power strip is held on using 2/3 of the clips that were included in the package. But I have them so close together because I had to use some holes that were in the monitor mount because this is a stainless steel desk, that if I don't hold the power strip while I plug things in, well, I might knock it off the desk. So, I guess also see if anyone is going to join me for my hastily scheduled live stream, because some of these ICs are not installed during parts of the assembly process. I am going to temporarily remove them until they're needed, just in case I have made a mistake. Because while I believe I can still order these ICs, I don't know that I don't necessarily have spares of all of them. So just in case. All right. So what I've done to prepare is I have fired up my oscilloscope and my multimeter. Though I don't know that I'm going to need the multimeter. I also have my benchtop supply, although I don't have a place where I can set it and you'd be able to see it. I'll have to find a place, but maybe it's a bit awkward to adjust the settings, so I'm going to leave it exactly where it is. I have, since I did find the manual for it, I have set it the current limiting to 50 milliamps, because that should be enough for what I'm doing. But if it proves not to be, I can always turn it up slightly. But that should be at least high enough that hopefully I won't hit it, but low enough that I probably won't burn anything out if something is shorted. Because I think most of the components on here are rated high enough. So, especially since I pulled the C's out. I also, let's see, anything else? Oh, yes. And I have my clip leads plugged into the power supply. In the last stream, I did adjust the voltage. And it should be outputting 3 volts. Although I guess I will double check, especially because now I have clip leads that I might theoretically be able to clip onto the multimeter probes. Maybe not. Okay, so I can't clip them onto those multimeter probes because the probe part is too short. So I will just double check using my handheld multimeter because I think the probes are actually long enough that I can actually clip. They have a little indentation that I can clip onto. And my handheld multimeter should be close enough. Go to DC. All right, it's telling me I'm at 2.947 volts. Which is possible. Oh, but I can also do this. I'll just double check. I just realized the leads I bought from Amazon that can plug into the benchtop supply have a oops. Hold on. Oh, I'm on the wrong range. Oh, no, it's probably because I didn't get a good contact with the conductive surface. No. Oh. Okay, so that is confirming that apparently this benchtop supply drifted a little. I'm trying to use the fine adjustment knob to, there we go. I think the knob could use a little deoxit. Okay, that is probably about as close to 3 volts as I'm going to get it. I'm hoping that extra 0.001 volt is not going to contribute much in the way of error in the test instructions. All right, so basically I have the build instructions on the one monitor, and I'm going to try to not cross the streams with my multimeter probes. Anyways, I'm just going to go down the instructions, and I'm going to validate things as it says to validate them. So the first thing I want to do is to double check the double check that I have the correct voltages coming to the main board. Whoops. Oh, I did not want to do that. Which I should, but I'm just going to double check it. So I need to find a contact that is on the ground plane, and I believe that is. So I should have, because the instructions, let's see, I've got an IC socket on IC9. Okay. So the instructions are using that point and this point to check 12 volts. 11.830. Okay, I believe that is within tolerance. And this next one, though, should be much closer. And it is, looks like it's this pin and this pin. Ah. Okay, so I'm going to have to adjust that just a little bit. That should be 5.333 volts. Although maybe for this test, I'll leave it exactly where it is, and we'll see what the oscilloscope tells us. But if I need to, I will adjust that. All right, so I have tested my adjustable supply. I've confirmed it's outputting 3 volts. All right. All right, so for this testing, they have connected the ground to the voltage regulator ground tab, which is actually a really good. I'm going to pull the heatsink off of it so I can actually clip that. That's actually a really good place to clip to, because it won't be in my way. I realize it's off screen, but okay. And they have connected the positive voltage to R90, which is this resistor here. Okay. So now I should be inputting 3 volts in to verify that your control voltage is correct. All right, so the control voltage, they are measuring between R90 and all right, 3 volts on the dot. Verify the op amp is working. Oh, okay. So all right, op amp. I did remove the ICs as a precaution, so let me reinstall the op amp. All right, notch to notch. All right. Now I will plug power back in. I think I may walk over behind my desk and plug this power adapter in somewhere where I can actually turn the power adapter on and off without unplugging it each time. I'll make it a little better on my sanity. All right, so we're going to measure here and pin 7. And I am seeing 2.999 volts. I believe that is correct. I believe if the op amp was not working, I would see it should be the same as the control voltage. Okay. use your oscilloscope to probe the sawtooth generator. Connect ground of your scope to a convenient ground. Not shown here. Oh, that's fine. I think a convenient ground would be the same ground tab on the linear regulator if it will reach. And probe to R105, which is right up here. Oh, that is going to be a bit tricky. But I think I can get that. And there we go. R105. You should center VR2 and TM4 and TM5. Let's see, center VR2. Oh, is that a knob on the underside? I bet that's a knob on the underside. Okay. So I am going to use my handy dandy camera. Actually, that's going to be the knob they're talking about. That's VR2. All right. TM4 and TM5 are these potentiometers that don't have a visible center mark. Well, I guess actually this one does somewhat. So let me I think I can. Unfortunately, I think these are multi-turns. So even though I'm going to turn it so that it looks centered, I have no idea if it's centered. Actually, I'd kind of really like to go get my. I've got a set of. Potentiometer tools upstairs. So I'm going to go run upstairs and grab those tools, and I'll be right back down. So, be right back. And I'm back. And so that my hair doesn't scare anyone off, I grabbed my hat too. Little bonus. And I plugged in the 9-volt adapter so that I can more easily cut power to... Oh, that's... to the adapter, and that's interesting. All right. Well, that is, of course, assuming that... Oh. Okay, that works. About to say if I can control it, because the app for the smart plug I have was complaining I'm not logged in, and I don't have a saved password in my password manager, but it still works in HomeKit, so good enough for me. Anyways, I went and grabbed my Avon anti-static alignment tools set that I bought some time ago from Amazon. I guess these would be the same type of things you might use to adjust potentiometers in TVs, because a lot of these are non-conductive. But the reason I grabbed these is because there is a tool that, yes, I could have found a thin screwdriver, a thin flat-bladed screwdriver, but I knew that set had a tool that was the correct size for these potentiometers. So that's why I just wanted to go grab that. It was luckily where I thought it was. So I have power again to the Zox box. I have centered those potentiometers as best as I can. And I am going to... yes. See that I have... See the following waveform with a 5.5 volt peak to peak. Let's see here if I can remember how to operate this. All right, so that's 5 volts per division. That's 2 volts per division. How about 1 volt? Okay. Well, that right there tells me that is... not one... Wait a minute. Yeah, that's not good. Because if it's supposed to be 5 volts peak to peak... that is not... That doesn't appear to be a 5 volt peak to peak signal. Unless I'm on the wrong... Well, let's see if I can't... Well... Wait a minute. Well, that is a sawtooth wave. I don't think it's 150 hertz though. That's 600 millivolt peak to peak. 7.5 millisecond. Something. All right. Okay, well, let me measure the DC bias. That will at least tell me if .3 volts. Okay. Okay, maybe I don't normally read oscilloscope screens, so maybe I was misreading the screen. That does have the right bias. Let's see, 150 hertz. Wait a minute. Will this show me? All right, let's see here. Source channel 1 type. Let's see, I want the okay, I want frequency. So let's see here. Probably help if I would read the manual. Let's see, where's the enter button? Oh, there we go. Let's see, I would like to see the amplitude. Well, that's actually not helpful. Let's see here. Okay, so that's 133 hertz. Which, interestingly enough, matches the screenshot that they have in their instructions. It also says it could be different than 150 hertz. Okay. Apparently, maybe I get the opportunity to tweak that later. But it says if I turn VR2, yep. Okay, you can't see me turn VR2 because it's on the underside of the board. Or, well, technically, the underside of the board is the side with most of the components. I guess in terms of the way the case goes together. So, anyways, if I turn VR2, I can change the frequency. If I adjust TM4, okay, yep, I can adjust the frequency. And if I adjust TM5, Yep, I can adjust the frequency. Okay, maybe that is working. Because I've got the right bias, I'm just probably not reading the oscilloscope screen right. I had a really cheap pair of headphones. Oh, bummer. I shouldn't have returned a really awful pair I had to Amazon. They would have probably worked. I don't think I've got any dollar earbuds. Unfortunately, the thing is, yeah. The thing is, the instructions do later elaborate why it says the instructions say really cheap headphones. And it has to do with the impedance of higher end headphones and audio stuff that I don't remember what I read. But, anyways. Okay. So then it has you do some more stuff. And it has you put the control voltage on R90. And then you probe the waveform switch pin. Although first I'm going to measure the bias. So it's the second from the top. And that should be about 4 volts peak to peak and 7 volts DC bias. So that's, well, okay, it's reading 6.8 volts. Probably close enough. Okay. All right. Let me take the oscilloscope probe off that, and oh, I wish there was a component I could clip onto, but I guess I'm just going to have to hold it. Whoops. And lose the ground. All right. This may be far enough over. I may have to find another ground attachment point. Okay, that is a square wave. It does not really look all that square, like the instructions. Oh, okay. Well, I think it's working right. I just I don't have a good place to clip the oscilloscope. So I'm going to call that correct. Yep. Same frequency it was. Yeah, it wasn't super square. Okay, yep. I had right about the right bias. Solder the remaining parts. Ah, okay. So, all right. Let's see here. Let me cut power momentarily. Confirm that I have. Yep. Because I need to insert the other two C's because they would have been included in the solder the remaining parts. All right. All right. So let me make sure I've got Okay. So I need to tweak the adjustment of the 5.333 volts slightly. I think I may use my, well, if I can find a place to clip the oscilloscope to, but I don't think I've got one. I was going to use the oscilloscope to help me. But I don't see, because I can actually clip the oscilloscope. That will help while trying to turn the potentiometer knob. All right, well, barring that, I will... Oh. Okay, I can, however... All right. Take the... All right, let me take the leads I was using to supply power and put them in my multimeter here. I think the banana plugs will insert. All right. So I've got the ground clipped to the voltage regulator, and I'm going to, I think one of these resistors is on, I think there's a place I can clip and be on the 5.333 volts. Let's see, where are they getting that from? It was... Okay, so it was that pin. It was pin 1 of this IC. All right, is there a component? Component is that pin connected to? Where's that? I'm trying to see if there's a component that I can clip to. That's IC9. Let me see if I can pull open the schematics real quick. Okay. Oh, that's the wrong schematic. This should be the voltage-controlled oscillator. I am looking for IC9. Pin 1, oh, is connected to +5. Ah. Okay. Okay, let me go back to the I/O board, because there's no place on the main board I can clip to. That voltage is being generated by the... No, there's nothing I can clip that to. All right. All right. Well, if I can't clip, then I want my good the. All right. And I'll just have to do that. Oh. Turn on power. All right. So it looks like I did previously calibrate this power supply, but it looks like the addition of components has well, actually that doesn't surprise me because there's I calibrated it on the supply itself, but now I'm measuring it on the at the source that's using it. So, and this is an important voltage. That's why I'm using my good multimeter. That's weird. All right. 5.333 volts. Okay. I think that is I think that's good. All right, let's go back to the instructions. All right. All right. So what I'm supposed to do with VR2 centered, and that's the one on the bottom, is I need to switch between 2 and 3 volts. Oh, okay. I'm going to take an out. Instructions say I can delay the calibration steps until the rest of the synthesizer is completed, where you can press a button to generate 2 and 3 volts to the VCO. And I'm doing that because this bench power supply, there's not a way I can switch between 2 voltages without turning knobs and just having a frustrating time. So, because apparently I need to first adjust TM4 and TM5, which are these two potentiometers, until the frequency at 5 volts is double the frequency at 4 volts. I mean, the frequency at 3 volts is double the frequency at 2 volts. But then I go to set to 2 volts and then adjust TM4 until I see that the frequency is 65.4 hertz, which is C1, the note C1. Part of me says, well, maybe I can just set 2 volts and tune TM4 until I get C1, but I think I need to follow the directions and have fun. Yeah, I wish I could have ordered the potentiometers, or I wish I could have found the potentiometers like they used in the kit, but for some reason I could not. Well, maybe I didn't realize what I needed to do and I unnecessarily. Oh, I unnecessarily bought fancier potentiometers. Oh well. Okay, let's go to testing the VCF, because I can at least do that. Okay, so I can power up and connect 3 volts. All right, yes, I can do this. This is, all right. So I can connect 3 volts, and I have my bench supply already set to that, and we inject it at R90. So okay, we should have 3 volts going in, and okay, so it says to twist VR3 and VR4 all the way down. And we should see an almost sinusoidal signal. All right, so where do I need to put the... It looks like the oscilloscope is... Oh. Oh, I need to probe the potentiometer. Fun. All right, that worked. Unfortunately, I probably need to clean flux off the board, which I haven't received my flux cleaner yet. All right, so I need to probe, I think, this pin. I don't know that that's going to stay very well, but we'll try it. All right. Okay, well, that actually does look... All right, so I need to turn these 2 potentiometers all the way down. Is that right? Doesn't look right. Well, now that looks sinusoidal, and there I see high frequencies. Hmm. applying the right voltage? This is weird. Okay, so I turned both those pots all the way down like the instructions say to. I have no signal at all. I don't know. It almost looks like I might have. VR3, VR4, VR5. Well, maybe it will behoove me to turn the board around so I can make sure I'm twisting the right potentiometers. No, my oscilloscope fell off. VR3, VR4. I think that's all the way down, and okay. Let me double check that I've got the right potentiometers. All right, so VR4 is a linear dual potentiometer. All right, so if I so VR3 should be a logarithmic potentiometer. Not sure I can. All right, one thing I can double check that it's a 50K potentiometer. All right, so this should be VR3. I think. Okay, so that's all the way to one side. I'm pretty sure those are the two pins. The multimeter is going crazy. Oh, that's weird. Okay. Let me check this other one because I am not 100% sure how. I'm not sure those are the right potentiometers. All right. Let me look at the parts list. I mean, it looks like it's behaving like it's supposed to, but it's not, because if I turn them all the way down, I have no sine wave at all. If I turn them all the way up, I do see the high frequencies. So that tells me that I might have ordered maybe those are linear. Thing is, there's both linear and logarithmic potentiometers that are 50K, and I thought I separated them. Maybe I got them mixed up. Let me go grab the potentiometers I haven't used yet. Well, the interesting thing is, though, so those are the potentiometers I ordered. There are a total of 6 50K potentiometers. However, one of them is a dual potentiometer. So it has, and it's this one right here. It has way more pins than the other. So I kind of mixed it up. Anyways, it's linear. It actually does say, I probably should show the screen. So the potentiometer I have in VR4, which is one of the two I'm turning, does actually have a B50K on it. So I am pretty sure it is a linear dual potentiometer. So I think that one is correct. The one that I'm wondering if it's incorrect is going to be the one in VR5. So, but I ordered 3 of them. Now, this is a case where I think the part I wanted, I'm not sure if I was, let me see here. Some of these potentiometers, I had to go for what Panasonic claimed was a direct replacement. And it's possible that if maybe I did something wrong when I ordered the direct replacement. So I should have ordered 3 50KD log potentiometers, which is EVU 2FL or F2L FL 3D VR54. Okay. Which is what I ordered. I have one left because yeah, there's one in VR3 and there's one in VR5. Wait a minute. Let me double check. Am I turning the right two potentiometers? VR3 and VR4. So VR3 and VR4. Because that one's VR5. I'm pretty sure. Is that how they're numbered? Yeah. VR2 is on my right because the board's upside down effectively. So VR2, 3, 4, 5. Okay. So I ordered three potentiometers of one type, and I guess see what I'm pointing at. So there's three of these potentiometers. One I haven't installed yet because I have not reached that step. One is here and one is here. There are markings on the potentiometer. But I'm having trouble reading them. So I will attempt the little USB microscope, and of course, it's just going to come off its stand for me because it knows how much I don't like to. Okay. This M, which I presume is, although interestingly enough, that's Panasonic. I don't know why it's an M, but anyways, 50KD. 50KD, a logarithmic potentiometer. 50KD. All right, 50KD logarithmic, 50KD logarithmic, VR3, VR5, and VR8. 50KD. So this was a logarithmic. Now I guess the question, it does beg the question. All right, so that one is correct, but I guess let me double check that VR3 and VR5. Okay, 50KD. That's VR5. I guess now that I know that I had you upside down, I'll turn you right side up. So, okay. So VR5 is a 50KD. So that's correct. Just so you can see, that's VR4. I know that's B50K. That's the correct marking for that dual potentiometer. So VR3 does say 50KD. Yeah, that is a logarithmic. And just for comparison, though, VR2, sorry about that. VR2, though, should be I think is a linear. So 50K B. Yeah, is a linear. VR2 is a linear. So, okay. So I have the correct potentiometers on the board. So that's, I mean, it's possible maybe these two potentiometers are just way the wrong value. I don't know where their middle, well, actually, I do know what their middle point is. I just go back to the voltage controlled oscillator instructions. Oh, first, I want to measure the resistance of this other 50K potentiometer. I just want to sanity check for myself that if I do turn it, that I do get 50K when it is at one of the two extremes. Just a sanity check that I'm not forgetting how potentiometers work. I'm pretty sure it's not the inner and outer. Let's see here. So that, okay, so that's 3 ohms. That must be minimum. So if I check here, oh, yeah, 50K. Okay. All right. So I did, so I, okay, so I sanity checked that the potentiometer that I haven't soldered is a 50K ohm resistor. I will take the markings that it's actually a logarithmic one like it's supposed to be. Although I am going to double check that these linear ones that I haven't used do have the B marking on them. I think now that I know how Panasonic marks them, I can maybe see it without the microscope. Yeah. I'm pretty sure it's a B. It looked like a little 8, but I'm pretty sure it's a B. Okay. So okay. So I'm pretty sure I did put the correct potentiometers on the board. All right. Next step. Let me see if I can't unclip a couple things because I got so many wires going so many different ways. Double check the power's off to that. Yes. Okay. The next thing I'm going to do, because these are like 12 turn potentiometers, because I don't know why I don't know why I did not order these. I don't know if it's because I was not able to quickly find these. I don't know if maybe I stupidly did something like, ooh, these multi-turn ones are more precise or something like that. So I can't just turn them to the middle. But I can turn them to the middle if I take my ohm meter, and I'm going to use the one I can see better. And I'm going to turn those potentiometers to their middle point, assuming that my multimeter actually can read them decently, and that now that they're in circuit, I don't have my multimeter doesn't start to read other things in circuit or have trouble with the flux. All right. So I think this is one of the potentiometers in question. So currently it is set to overload resistance. So that doesn't make sense. That really doesn't make sense. Okay, I am going to find my bottle of isopropyl alcohol, which I probably, put on the other table while I was installing window film. Despite the fact that isopropyl alcohol is not one of the things needed for window film, I'm going to take my toothbrush of it's never been in anyone's mouth and never will be. And I'm going to clean the flux off of the bottom of the board where these two potentiometers are. So that I can get a better read on them. So let's see here. So one of those potentiometers should be there. These 3 pins here. So I'm just going to try to carefully clean and yeah, for those of you that might have realized I have an ultrasonic cleaner, the reason why I'm not going to use the ultrasonic cleaner is because these potentiometers cannot go in the ultrasonic cleaner. I would have to desolder them. And then I could put it in the ultrasonic cleaner. Also, I don't have any ultrasonic cleaning fluid for flux removal. That would probably be the more important reason I'm not using the ultrasonic cleaner right now. Is I don't have cord cleaner. So isopropyl alcohol is just going to have to work in a pinch. Since I don't have spray flux remover. I will just have to, when I'm done building this board, I'll either have to break down and desolder the potentiometers and then ultrasonically clean the whole board and then put them back, which seems like an awful lot of trouble. And plus, the other problem is that I would still have flux on the board when I was done, although maybe not as much. Or what I'll probably more likely do is, apparently these potentiometers, at least on the data sheet, they say you could, if you were doing assembly, you could do a low pressure spray cleaning. So what I may do is get some flux remover cleaner that's designed to be low pressure sprayed and just very carefully take the board outside and low pressure spray it, and then or gently pour flux remover down the board. Maybe trying to avoid directly getting the potentiometers. I don't know. I'll think of something. Okay. And now let me go get the paper towels, which are over on the other table. Although, at least in that case, I do know why the paper towels were over there. Because I was installing window film and you have to clean the windows first. So I know why the paper towels, but no, I used window cleaner for cleaning the windows, not isopropyl alcohol. I must have cleaned something else over there. I'm just kind of doing this to try to make a mess of little paper towel pieces. All right, I'm gonna do one more scrub. And I'll let this try to air evaporate. Except what I managed to get on other things on the table. I will wipe them up. Unfortunately, this is like only 70% isopropyl alcohol, so it's going to take some encouragement. Actually, I've got a microfiber cloth, I think, that I will sacrifice to the live stream. There we go. I don't ever, well, I've got enough of these microfiber cloths that I'll just find another one to put in my lens cleaning kit. Although the thing is, usually, at least with camera lenses, usually I'm good about not touching the lens. But if I've slarmed it enough that I need to clean it, I usually need to use a lens cleaning wipe, not a dry cloth. So I'm okay with there. Well, it's no longer a lens cleaning cloth for sure, because I'm sure there's flux residue on it now. You want to talk about slarming up a lens, I'm pretty sure flux would be a good way to do it. Or maybe, as I should have said, a bad way to do it. Okay. Ah, well, that's better. Okay, so I think that's one of the potentiometers, and I think this one might be the other one. Yeah, all right. That's better with that flux. I mean, it wasn't the best cleaning, but it did just enough. All right. So that is TM5. TM5 is a 5K potentiometer. TM5 is currently 2.59, so it's about 2.6. So I think I'm going to turn it like about a quarter turn to my left. And let's see. I'm just trying to center it like the instructions are asking. So I'm trying to get it to about a little closer to 2.5, which should be at center point. No. Okay. That was the wrong direction, at least from the point I'm measuring. So let me turn it half a turn to my right. And that might actually put it right at about the middle point. I'm gonna get it closer. May not be exact. 2.523. Yep, okay. Actually, I'm gonna go for one more quarter turn, which would actually put the threads parallel with the short sides of the potentiometer. Because that kind of about would be where I would think the middle point would be. And nope, that was too much. So I will No, I think I had it about. I think it's really about where I want it, right there. Oh, I'm still using you. That's a little bit more. A little bit more. $2.508. Good. Okay. I'm gonna call that's definitely should meet. Be close enough center. Okay. So TM4 is a 50K potentiometer. And it is currently 13 14 kilo ohms. So I need probably okay. Yeah, I went half a turn. It's probably actually close to a full turn, at least a full turn off of being centered. Okay, so that's one turn. And if that's okay, I'm going the wrong direction, which is weird. No, because I got the two directions mixed up. I need to move it up. Okay, so I just moved it by 3 turns because it was like am I even on the right pin? I may not be on the right pins. No, those are the right pins because it's reading 14 kilo ohms there and oh, that's weird. Let me double check that I had the actually maybe that's the problem. All right. TM4 is Oh, I believe it's a 50K potentiometer. It's just like, I don't know how many turns it is. It might be a 20 turn potentiometer. All right. I just made a big move. Weird. I'm it's like, oh, I'm turning it the wrong direction. All right, now it's reading about 14.5 kilo ohms. That's about where it was to start with. Eight kilo ohms. Huh. You know, I think that might be the culprit. All right, I want to turn this potentiometer all the way until it stops. Which, I turned it all the way until now it's reading 0. So now I'm going to turn it all the way. And it never stopped. It just started clicking. And I'm going to turn it all the way the other way because it's marked as a 50K ohm potentiometer. But it's acting like it's more a 25K potentiometer. Or at least it's acting like it's the wrong value. 10K. Zero. Yeah, it's acting like it's a 10. I don't know. I think the and yes, I have power off to the power adapter. I guess I could probably just unplug that at this point. Okay, so I believe, yeah, I think I believe potentiometer TM4 that I installed is defective. It's not. It's marked as the correct value, potentiometer, but it is not because it looks like, and I'm actually going to pull the schematic up here real quick to double check it. It looks like the circuit is actually using both sides of the potentiometer to do important music generating activities. Let's see here. So TM4 is right here. TM4 50K. So the 5.333 volts comes in, and $12 volts. Okay, I don't know exactly how that potentiometer is doing what it's doing, but I believe by looking at the schematic that if this was not a 50K potentiometer, well, that I guess could explain some of the weird things that I was seeing. Well, unfortunately, I'm going to have to order potentiometers. So I guess if you noticed something I overlooked, then you can post a comment in put a comment on the video, and I'll go look at whatever you suggest if you think I maybe overlooked another cause of the problem. Or if you noticed as I was probing on the board, I was measuring the potentiometer wrong, but that potentiometer, it is marked 503, which actually W503, which does match that TM5 is marked W502, which I believe is the 5K indication, and it is TM5 is acting like the 5K potentiometer, but TM4 is not acting like a 50K ohm potentiometer. So I'm going to have to order a replacement. I don't think I have any, because it looks like I'm just taking a quick look to see if there's any. I think I've installed all the little trim pots that were destined for this board. I'll double check the bomb, because if I find that I've got one in the box over there, then I can use it. No, I don't see any other trim pots. So, yep, I'm glad to order. I did not order. I should have probably ordered spares of some of the fragile components, but I did not. And now that I'm putting the board together, I have discovered that was a mistake. So, yes, I guess I realized that if I was putting this together as a kit, then yeah, I would have... Well, I mean, if I'd found a defective potentiometer and I'd ordered the kit, then Adafruit would have replaced it. Sent me a replacement, most certainly. But they didn't have kits when I ordered this. I just ordered the circuit board, so I ordered my own components. And yes, I should have probably taken the opportunity of realizing that the trim potentiometers were probably fragile parts and ordered a spare. I mean, there is one other possibility, and I guess let me see if I can find them on the circuit. There are two PTC thermistors. They are R100A and R100B. I believe they're here. Oh. But no, that would, those, if I had the, basically, I installed the ones I'd ordered, which are, they look different than what Adafruit used. But I'm looking and I don't know exactly what they're doing in the circuit, but if I had the wrong values there, then well, I don't think it'd cause what I'm seeing. Because it looks like they're in parallel. They're 1K thermistors, which are then in series with a 27K resistor, to then go in series with one of the legs of the 5K trim pot. Which looks like that's being used to adjust the up amp. Ah, okay. That looks like that's the feedback, possibly in the feedback circuit for the op amp. Okay. I guess maybe that's trying to apply some thermal adjustment or something. I don't think that's the cause of the problem. I mean, that's not to say that I had that maybe one of these transistors might be bad as well. But considering that potentiometer is supposed to be 50K, which would mean I should be able to find the center point at 25K on it. And it started off reading at 14K, but now I can't read anything above 10K on it. I suspect it's defective or broken. Maybe I broke it when I soldered it. I mean, maybe I dwelled a little too long on it when I soldered it. And anyways, I'm going to call it is candidate A for what I did, what's broken. Although, if I do order more potentiometers, I was going to order some spares. Oh, excuse me. I was going to order some spares of some of these ICs, especially ones that had stock. Especially some of the ones that Mauser had 2 in stock, or well, they were showing 7 in stock, but they would let me order up to 2 without back ordering them. So those are going to be in my order, assuming I don't miss the opportunity. I'll make sure I order potentiometers, some of the ICs that I might accidentally destroy. I was going to order a spare uh, EEPROM, or I guess it's an EEPROM. Although I can't get the dip part anymore, but the the dip part was discontinued. No big surprise. But the surface mount, I forget what the package name is that has the leads on it. You can still get it with the surface mount with leads. I was going to order some of those just in case I have a problem with one of the EEPROMs. Because I think I ordered one, and I think the eBay auction I won had one in it. I'll get some surface mount ones. Worst comes to worst, they make little adapter boards to adapt those surface mount parts into a IC dip format. Luckily, I believe they're pin and they're electrically compatible. They're the same part. It's just surface mount. I guess one benefit, I think the surface mount part's cheaper. So, and apparently there were plenty in stock. So, yeah, I'll order some spare parts of the ones I don't have spares of. I mean, I've got spares of the transistors to some extent. I think I have some spare op amps. But some of the other standard logic chips, I'll order some spares when I order the potentiometer. And I'm going to order ultrasonic, the flux remover fluid for my ultrasonic cleaner. I'll order a bottle. I'm trying to find a place where I can order what Steve and Jay use. Maybe they'll be kind enough if I ask them. Maybe they'll be kind enough to let me know where they order it from. I can't seem to figure out which of the distributors I normally order from, if any. Well, okay. I found one of the distributors I order from is a Branson distributor, but they don't sell Branson EC, which is what Jay and Steve use. They sell the other Branson fluids, but not Branson EC. Which, considering that vendor is Granger, I guess I'm not too surprised. However, it beats me if any of the electronic distributors. I have yet to find one of them that sells Branson fluids. So I found some places that sell it, but I don't know. Maybe if I had a recommendation, then I'd be more willing to place an order from one of the places I found, knowing that they're probably legitimate. So it's like when I find a website that's to some extent, I guess, for example, you find a website well, okay, bad example. I was about to say shoes.com, but I think shoes.com, the company that used to run shoes.com, went out of business. And so that was a bad example. I believe shoes.com is a sketchy site now, or at least one that I am not, I would not order from. I can't remember what loads if you go there. But anyway, I was going to say, I'm trying to think of another example of a generic worded site that took off. Because shoes.com used to be a place where you could order shoes. They had plenty of brands. They were definitely, I mean, I'd ordered from them before, I'm pretty sure. But I think the company that ran them must have gone out of business several years ago. But someone, I guess I discovered in that someone must have bought that domain because I get spam emails that claim to be from shoes.com. However, because they like started coming out of the blue, I'm like, this is weird. And I started looking into it and realized that, oh, whoever owns the domain now is not the same company that used to own it. So, yeah, they're that domain's in my blacklist now. So, um, so what's another? Anyways, I found some websites that sell ultrasonic parts, and they have like ultra generic domains, and I guess it's kind of one of those. I'm not sure. It's kind of like some of the websites you find now that you do a web search and you find all these websites that seem to have information, but it, once you start reading them, it looks like they've taken someone has taken information from multiple websites and put together a top 5 list, and you start reading through it, and it seems like some of them conveniently have what you're looking for in their top 5 list with affiliate links, or you'll find a website that they sell stuff, but they conveniently have lots of blogs that don't really specifically give you a lot of information other than order things they sell. And it's, I don't know, the don't is it the AI is taking over the internet? Is it the people that are just trying to make a quick buck by making review sites that really, if you really look at it, the reviews seem to be scraped from places and they're just trying to get a quick buck from an affiliate link? I don't know. But anyway, it's kind of one of those. Are these places that claim to sell the ultrasonic fluid I'm looking for? Are they really selling it? Because actually, one of them I went to, I think I went to the purported link for the ultrasonic fluid, and it redirected me to Amazon, which kind of, and maybe that's now why I'm thinking some of these other sites, are they really an actual web store? Because one of them has already proven that it redirected me to an affiliate link on Amazon's website, and it was Amazon. But the thing is, no one at the link there was nothing in stock. In fact, Amazon did their when there's no one selling it and it's not something they stock. I got the currently unavailable. We don't know when it's going to be available again. No third party seller options. It was like, yeah, Amazon wasn't the seller. Uh, Maybe this website used to sell it on Amazon, but not anymore. But yet their website still has it listed. I don't know. It's just kind of those annoying things about the web in 2021. The websites that aren't what they seem to be, but yet have mastered search engine optimization so that they're your top search links. So, and I don't know if they've mastered search engine optimization on all the search engines, because I've been trying to use DuckDuckGo lately, but I have to admit that there's been a couple web searches where I had to actually go fall back to Google's to actually find what I was looking for, because DuckDuckGo didn't find anything. And in fact, one example was this DC power benchtop power supply. I was trying to find the manual. Uh, DuckDuckGo came up. All the links had nothing to do. I found a data sheet using DuckDuckGo, but that wasn't the instruction manual. So I went to Google. Yeah, Action Retro. I went to Google's website, and unfortunately, Google actually had in their websites they queried, they actually had a website that had it was a very poor scanned copy of the manual, but it was better than nothing. So, well, I'm still using DuckDuckGo, but I guess that was at least one example that I got disappointed and Google actually had the result and DuckDuckGo didn't. So, and I guess the other thing is, yeah. Anyways, so hopefully at some point I will manage to get ultrasonic fluid, cleaner board flux remover for the ultrasonic cleaner. And my fallback is I'm just going to order a gallon of the Chemtronics because I think Mauser sells it and had plenty in stock, and it was $42 for a gallon. I don't know how well it works. Maybe it'll work well enough. Maybe considering the how dirty the boards for the Amiga are, that I'm going to need to clean them before I start working on them. Maybe that would be a perfectly good fluid to use because I'm probably going to dirty the fluid way quicker than um, anything because of how much dirt is on the board. So maybe having a gallon of that fluid would be good because I suspect the Branson EC is probably closer to like $70 a gallon if I had to guess. Maybe more. It's hard to guess what it usually goes for, and based on what Grainger charges for other ultrasonic fluids from the same manufacturer, is Grainger's great when they have things, and they do have some really nice things in stock, but uh, you can pay a slight premium sometimes with Grainger. But I still order from them for some things because they do have a good selection and they're always quick to ship. And no, I'm not sponsored by them. I do just, I'm a customer and repeat customer because they've treated me well. I guess the same with like Newark and Mauser, and I mean I'll even order for I've got an account. Well, I guess an account that I've got a login and I've successfully ordered. I don't have like an account, but even I've ordered from DigiKey and Arrow, and I was wanting to say there was even one more electronic distributor I might have ordered from. No, I guess. Oh, that's right. I'm thinking of Grainger. No, not Grainger. McMaster Carr, but they're not an electronics distributor. I was just thinking that. Wait a minute, I've ordered from somewhere else for the Zox box, and that's right. I ordered the fasteners for the Zox box came from McMaster Carr because that's probably where Adafruit sourced them from. And fortunately, when I ordered them, I know for the longest time McMaster Carr, it was business. You could business only ordering, but I guess when I ordered the fasteners, I guess they went to either they went to uh, allowing personal orders, or maybe their official position still is business only, but they certainly let me order fasteners. So thank you, McMaster Carr. That made finding the fasteners a lot easier. So yeah, um, and actually, I have to, I guess, admit that when I get to the fasteners and pulling them out of the boxes, I, I, I definitely will be able to quickly find the fasteners the way McMaster Carr packaged them. So, but well, I gotta get the boards working. So, anyways, yes, as one of my coworkers puts it, short story long. It looks like I'll be ordering at least a potentiometer, if not some other spare parts. Hopefully that explains some of the weirdness I saw on the signal while I was probing with the oscilloscope. I mean, I guess if that resistance was off, it would have affected it. Probably, yeah, it would have affected the frequency. I would have not been able to get to a frequency of 150 hertz because the potentiometer, there's no way I would have been able to get the potentiometer to 25K, which would be the midpoint where I think should have seen something closer to 150 hertz. So, yeah, that might explain it. I hope it explains it. otherwise, well, I'll be hoping that somewhere on the instructions for the Zoxbox there's some more detailed uh, troubleshooting of if you see this, then check this. I'll have to check that. I guess first, let's make sure I get a potentiometer that I can set to the midpoint, and the midpoint is actually the valid midpoint for what the potentiometer is supposed to be, and hopefully we'll go from there for troubleshooting. So I think that I will put the Zoxbox on the shelf until I can get some spare parts, because I don't want to add too much more to it knowing that there appears to be a problem somewhere, because the more components I add, the harder it's going to be to get. I mean, honestly, it's already hard enough to get a clip lead in some of these places, but if the, I mean, I may put more parts on the I/O board. I may do that because the I/O board is separate, even though the power's running to the main board. I can build other things on the I/O board, and I'm not as worried on them. In fact, actually having some of these other things on the I/O board may make some of the other testing go a little smoother. So I may skip to the I/O board assembly and go ahead and I can build up the circuit for the serial chip. Actually, that would be nice to know that it works, because if it doesn't, then yay, fun times ahead. I don't have a spare, and it is, the good thing is it is an FTDI serial chip, but the bad thing is I think the particular chip that is used was obsolete when I placed the order, and it's the original chip that Adafruit used was discontinued. There was a pin-compatible replacement that I think was obsolete when I ordered it, and I believe that pin-compatible replacement is now discontinued because it's been 4 years since I ordered the parts. I actually went back and found the original order. It was like October of 2017 when I ordered the parts for this. So yeah, it's taken me 4 years to get to this point. Maybe I should have had a birthday cake or something. Just celebrate the... No, that's not something you celebrate. Anyways, yeah, I do believe, though, I did notice that Adafruit managed to find some of these FTDI chips in their stock. I guess they realized they had some hiding away on a shelf. And I believe it is the chip they used on the original chip they used on the Zoxbox. So I kind of would like to know that works. I don't want to order those chips if that does work, because I'm not going to design anything that uses a chip that's obsolete, because I wouldn't be able to get any more. But if that chip doesn't work, then what Adafruit was charging is a bargain compared to the other possibilities of sourcing FTDI chips that are discontinued. Because unlike other parts on this board where I would feel comfortable sourcing them from some of the Chinese places that stock old stock chips, new old stock chips, FTDI chips is one of them that I really don't want to order from those places, because they're just like Commodore SID chips. They're in the category of chips that are more likely to be counterfeit or just not work, because apparently there's a lot of counterfeit FTDI chips out there. And yeah, I mean, I realize some of those counterfeits probably would work correctly for this project, but I don't want to risk it. This project's, by the time I actually finish it, I'm going to have so much time and money invested in it that I don't want to risk it with a counterfeit FTDI chip, because plugging this into MIDI on to be able to control it with a computer is one of its benefits, and I don't want to lose out on that. So, anyways, I've rambled long enough. If you want to know when I go live next, which could be the Zoxbox IO board, or if I manage to order potentiometers before I think I'll get to, might continue debugging and then I think build the next circuit, which I think is I want to say is the voltage controlled. No, it's the envelope generator. Which has to do with the envelope. I'll look that up, because I'm sure you're probably wondering, and I'm now trying to remember what the envelope is. I'm sure it has something to do with the attack, decay, sustain, release of, like, your FM synthesis. Because basically the Zoxbox is doing FM synthesis. Anyways, this right here is where the envelope circuitry is. So it's not a lot. So yeah, if I could get kind of get to the point where I think these circuits are working, yeah, that should be quick to put together. So, yep. If you want to be notified when I do Zoxbox, or probably next stream will likely be an Amiga stream, or if maybe I even go back to a game stream, if you give me a follow on Twitch or a subscribe on YouTube, ring that bell icon so you'll be notified. If you noticed something, if you're watching this stream on a replay and you notice something I overlooked or missed, or even just want to make fun of the fact that I did not read the oscilloscope manual and maybe should have, leave a comment down on the video and I will make sure to add it to the list of troubleshooting things to try. Especially if you notice that I was measuring the potentiometer wrong, although I'm fairly certain the middle pin was the center tap on that potentiometer, on all these potentiometers. Let me know, and because if you notice something, you might save me from ordering potentiometers when I don't need to. So don't worry, I'm not going to order them tonight, and it probably would be this weekend before I get to it at the soonest, because honestly, I would like to order caps for the Amiga at the same time. So, yeah, you might have a couple days, if you notice something, to leave a comment on the video before I would order parts, because you might save me from buying something I don't really need, or maybe you realize that there's a good chance I need to order something that I am not expecting. If by chance you really suspect that one of these other potentiometers is incorrect, even though the part numbers seem to line up, let me know. Because quite honestly, I'm probably not going to have a big enough order to get free shipping, and I'd prefer not to pay $9.99 shipping multiple times, because that really adds up. In fact, $9.99 could buy me 4 days worth of coffee, or thereabouts. And of course, speaking of coffee, I do have a Buy Me a Coffee. There is a link in the video description, if you feel so inclined to help perk up my mornings. It would be such a kind gesture, but I'd also appreciate all the free things you can do that help the channel, like liking the video, commenting, subscribing. Those also do help, because it's a small channel right now. I'd like to grow. So with that, it is time for me to get ready to retire for the evening because tomorrow morning is going to come so early. And I do need to make sure I'm well rested because I have 2 hours of training to look forward to at work in the morning. I'm sure it's going to be really fun training because it's the annual EHS training and they have to do it, but a lot of it is the same information each time that, well, I guess some of it I do manage to forget over the year, which is probably why they do it every year, but yeah, it's kind of one of those things that you tell me I have 2 hours of EHS training, and yeah, I'm kind of dreading the morning. You tell me I have 2 hours of innovation time, and I'd probably be excited for the morning. Yeah. If you're in software development, you probably know the feeling. So, anyways, yes, I am going to go get ready, so I'm going to be refreshed for work in the morning, and will hopefully feel safer by lunchtime. So, with that, have a great evening, and see you next time.